Well, I think we're at the top of the hour, so we should probably go just to stay on schedule and respect
Okay,
your time today, Ed. So,
thank you.
welcome to everybody to the Create Energy Innovation webinar series. Today, we are pleased to have a presentation from Ed Franklin at the University of Arizona. Before I introduce Ed, I have a few announcements to share with folks viewing the webinar today. Um, First, just a reminder, our website address is createenergy.org. And if you visit that website, this is the page that you will see and where you can find all the resources for the Create Energy Center. And I would direct you just to a couple things on that site that may be of interest. The first is that Create is currently conducting a 5-year survey of stakeholders in the energy sector to get a sense of priorities, trends, and directions for the skilled technical workforce for the next 5 years. We actually have two versions of the survey, one for industry professionals and one for faculty and educators. You can see the links down at the bottom. It's a pretty quick survey, shouldn't take you much more than 10 minutes to complete. And if you haven't had a chance to take the survey yet, I'd encourage you to use those links to do so or visit our website and you can get directed to the surveys from there. Um, Second thing to check out while you're looking at the Create website, we do have some upcoming workshops for summer 2026. A few of our workshops have filled already, but we've got a couple of them that still have a few open slots. The North Carolina STEM Educator Energy Institute and the Madison Area Tech College Solar Plus Storage Institute coming up a bit later this summer. And there are travel stipends to help offset some of your travel costs, and Create also provides lodging and meals for those institutes. They are both 3 days in duration, and the links for registration can also be found on the Create website. With that said, I'd like to introduce our presenter, Ed Franklin. Uh, Ed is an educator in the Department of Ag Education, Technology, and Innovation at the College of Ag, Life, and Environmental Sciences at the University of Arizona. He teaches laboratory courses in ag tech management, and he began his solar background with Solar Energy International back in 2012, which is how I first met Ed, actually. Ed completed his the SEI Solar Certification Program and earned a Solar Associate credential through North American Board of Certified Energy Practitioners. He introduced solar PV to his electrical instruction at University of Arizona in order to improve student knowledge and understanding of series and parallel circuits and Ohm's law. Dr. Franklin participated in the Create Energy professional development workshops that I just mentioned previously, and has been a participant both in solar PV and biofuels and virtual workshops spanning multiple years. He also teaches an online general education course called Energy Sources of Arizona and the United States, and he conducts outreach in solar PV and wind energy to ag instructors and students. Also, I should mention Ed is a certified drone pilot and teaches students seeking to complete their FAA Part 107 certification. So with that, Ed, I'm going to turn the slides over to you and let
Great.
you take control of the microphone.
Excellent. Thank you. Ken, let me see if I can get over here to share. Let's see, it's share settings. We go. Here we go here. There we go. Okay. All right. Are we seeing the,
Right now, I'm seeing your email.
whoops, okay, wrong one. Go back into the share thing again. That's the wrong
It's all
slide
right.
here.
It's an email from Gabby Temple at Create. Nothing embarrassing.
There we
No
go.
bank account numbers or anything like that.
Nothing yet. No, nothing there. How's that? There we go. That should be it.
There you go. You got it.
Okay, great. All right. Well, thank you everyone for joining us on a Friday. I know it's a challenging time. We have our university commencement tonight, turned in grades. We're getting finished here. So, but I'm glad that people gave some time to join us today so I can share what we did with implementing KidWind activities into our state FFA agriculture mechanics event. So we titled this University of Arizona, Our Journey with Wind. And let's see, that's not helping me here. Let's get back over here. I'm trying to find that slide. Oh, there we go. Okay, so I want to start first of all by recognition of folks who helped us out in this process. Michael Arkwin and KidWind was very supportive in our efforts during this project. Yvonne Cook from Kansas Energy was giving me a lot of great information about conducting workshops for teachers. Kathy Jackson, one of the first individuals I met at a KidWind challenge out here in Arizona. Remy Pangle for repowering, for helping to fund this project. Everyone at KidWind, that's been really helpful. And again, the folks at Create for allowing this opportunity to happen. So thank you to all. So background, I attended a KidWind challenge in 2023 in Pinal County, just north of us, met Kathy Jackson and getting an overview of just what the KidWind challenge was actually like. So this was at a middle school in Pinal County, just north of us here. And that gave me the first exposure to a KidWind event. We then decided to apply through a repowering school event. And I think the link that I actually found was right here off of Create. So thank you again for giving us the opportunity. We applied for funding. We wanted to be able to, in the future, host a KidWind site for our challenge. So the funding we used, we purchased a wind tunnel, a number of KidWind wind turbine kits, PVC pipe fittings, PVC pipe, wood dowels, balsa wood, the sensors, table fans, and everything that we would need to actually introduce this. And our idea was we're going to first introduce it in our AGTM class, lab class with our undergraduates that we work with on electricity, get them going with that. So in this class, we had 20 undergraduates. The course covers AC and DC electrical and wiring principles, electric motors. We've also involved solar PV in the past to produce electricity. We take them through series and parallel projects and Ohm's law and everything like that. So we introduced the PVC wind turbine projects as a group project, and then we brought in some KidWind wind turbine kits. So we started first with the PVC modules, very inexpensive, very basic, and allowed the kids to actually put them together. And so you see some examples of different projects there. And then we used the different activities from these different sources. Again, the basic wind experimental kit, renewable energy from Vernier, and then the building basic PVC wind turbines. So these were great materials for us to actually start integrating this into our undergraduate course. So this was in fall 2024. Our students are actually putting them together and testing them. We put them on a tabletop with a fan, and then we put them into the tunnel so they can see the differences and measurements as they start collecting data and understanding what this process is about. This was new to our students. We did not have very much of a background of KidWind, what was going on here in Southern Arizona. So then we thought, if we're going to expose our students in the state, we need to start with the teachers. So we conducted 3 professional development workshops. One was with Cochise County educators, which was west of or east of us. We worked with 12 educators, mostly middle school and high school over in Sierra Vista area to get them involved. Then we worked with our Arizona Ag Teachers Association. They had a professional development workshop in Phoenix in January. So the larger group down there had a lot of our teachers there. And we even had some folks from one of the Rice Intermediate Middle School, which is on the San Carlos Apache Reservation. So they actually attended the workshop as well. And so it was great to have a lot of these teachers actually involved. They built their own wind turbines, again, with the PVC model, very inexpensive to use. And we got them just introduced to it, because if we're going to put this as a team activity for the kids, we wanted the teachers to see, okay, what does that process look like? Get them started and, hopefully get them and their students engaged. And then we did another workshop here at the University of Arizona, and we had a smaller group of teachers actually attend that as well. This was a Pinal County KidWind Challenge in 2025. We took our tunnel over there and assisted the folks that were actually putting on that event, gave us more experience on how that challenge works at the local level. So our team activity in ag mechanics, what if you're familiar with, we host the annual state ag mechanics career development event for Arizona. And in our event annually, we'll have 5 individual activities. The students will come in and go through 20-minute stations. Problem solving is a component identification, operator manual interpretation, a lot of IEDs, and maybe some math interpretation or calculations. And we also have 5 skill activities, and typically they may be in arc welding, electrical wiring, PVC plumbing, woodworking, topographic map interpretations. These change every year based on the feedback from our high school agriculture teachers. We also have a team activity. And so there's 4 members in a chapter, and they'll work to solve a problem or do a construction problem. They'll do that on the front end of our event. So we are limited to 25 teams that come to our event. The winner will qualify to represent the state of Arizona at the National FFA Ag Technology and Material Systems event in Indianapolis. So at this field day, we'll actually have almost 3,000 students will attend this event. There's about 26 different CDEs, and they can range from livestock judging and equine and landscape and nursery management. So our event, Ag Mechanics, is just one of those events that take place during that day. And again, we try to get our information out to the teachers either in the summer or in October prior to our event in February so they can help give us insight of what they want to do. The team activity, again, this module is basically a little bit of what the national does. And so they have skills and then they have a team activity as well. So we try to model that on a smaller scale. The team activity, again, we try to do things here, which we give them about 30 minutes. And then we started thinking about how can we have teams do things at their own site and then bring it here to the university. So these are some of the past activities we did. We called it Build and Bring. We did solar fountains, and I think we did that about 2020. That was right after the pandemic. So we informed the teachers, said, hey, we're going to give you the information. We want you to have your kids build things at their school site and then bring it here, and we'll evaluate it, judge it, let the students present it. So the solar fountains was the first time we tried it. The students really liked it, came up with some various examples of very unique projects. We gave them a 20-watt solar module and then a pump, and they were actually able to create and demonstrate. The following year, the teacher said, hey, let's do more of that. So they came up with garden benches. So the students were able to build and bring down garden benches, put them on display. So we have examples here, a team that has their presentation board with information. We would ask them about, how they selected their design, chose the design materials, and how much work they put into it. So we had about 25 teams participating. They would bring these items down the day of the event. After they went through their individual skills and problem solvings, we would go out and interview these groups, and they presented. The third year, then we did chicken coops, something a little bit different. We tried to get away from the welding aspect and have them do chicken coops, things that they could use in their program. Most of the feedback very positive. Some of the schools that are smaller don't have the large vehicles to bring things down, where we're like, oh, this is getting too expensive and we don't have the resources to bring those down. So that made us think about what can we do something that's a little bit different, maybe a little bit easier on their budgets. And that's where we came up with doing the team activity with the wind projects. When we're doing something like this, the challenge is this is new. The teachers haven't seen it. The students haven't seen it, right? So to get them ready for the state event, we needed to go out to the regionals and introduce it to them. So in the state of Arizona, our FFA competitions are divided to 7 different regions. And so you can see here that we have all over the state. We have the northern region and Black Canyon region, Santan, and they all do their regional events early as November. preparing for our state event in February. So the goal was to find out what's the date of their events so we could load up our vehicle with our wind tunnels and all the testing materials and go up to their event, set that up, and then have those kids tested at the regional level, just like they would at a regional challenge before they come to the state event. So we had to figure out what were the dates and some of these locations. So the northern region, you know, it could be a 4.5 hour drive to get up to some of those areas. So we did the Northern District, and there was only 2 schools that actually had ag mechanics teams that were going to participate. So we set up our tunnel up there, and so these are some pictures of the teams that had their module or their wind turbine set up. We decided let's try to keep everybody equal. So we said we're going to go with the PVC turbines. And so, you know, the only difference between those and your regular KidWind large turbines are that they have a single generator and there's no gearing. And the basic difference is what the kids design as their the wind blades and the materials. We went down to the Santan Superstition region, a little bigger region. This one, we actually had to set it up outside. It was at a community college in Mesa. And so we had to set up outside the back of their welding lab. And we can see what we had. We did not have the ballast, for example. So we show you one picture here where the teams are trying to keep their wind turbine from turning over, being sucked into the fan. So they're actually laying down on the ground and actually hanging on to the wind turbine form there. And they actually used a different type of material. They were using fabric material as their blades. And then we saw a little tiny project that some student built with some popsicle sticks. And again, we saw some variety. So it was fun to have the kids. Again, we're seeing that creativity of what they can come up with. And again, introducing them, showing them the results. What we did is allow them to test 3 times and then submit the best energy score from the sensors as their team score. And again, all of these that were here were able to come to the state event. Again, just giving them an opportunity to test. The Gila Southern region, okay, here's what's going to happen, right? You're going to have 7 regions. They're going to have their dates. And of course, we had 2 regions that elected to have theirs on the same day. And the problem is they're about 75 miles apart. Mike, bless his heart, was able to send us another wind tunnel. So we were actually able to use one wind tunnel at one location, take one tunnel the day before to another location, set it up, train the teachers on how to use it, collect the data, right? So now we're able to do 2 on the same day. These were some kids at a school over in very eastern Arizona. We went out and worked with them and set up their project for them. Their teacher had gone to one of our workshops and she challenged the kids to say, hey, can you build one that beats my score? And they did, of course. Then we had the South Central region, which is at another community college, a little bit closer to Tucson. They had about 7 or 8 teams there. So we can see we have it set it up in an auto shop. And then the kids that were participating in that event, we gave them, again, multiple opportunities to record the highest scores possible. So they're changing out things here. Black Canyon region, this is up in northwestern part of the state. Again, very small region, had 2 teams that actually brought their devices and we tested them there. We also, in one of the events, here we go, we actually did a problem solving where we had them do an ID. So we came up with an ID event where we had 25 items related to the KidWind wind turbines, and they had to ID. So we gave them, here's a multiple choice. And so these were the components that were actually, they would build out of PVC, but they would also see different components. So we want them not only to do this with the team activity, but as a part of the problem solving, they again have a background on the KidWind that's coming in here. And this was another big region. It probably had 7 or 8 teams that were bringing this, and this was in a welding shop at their school. Yuma region, way out on the very west side there, they had a field day going on. And so again, we took our wind tunnel out there, set it up in a classroom, and the kids were practicing on it. So again, the idea was we didn't want the state event to be the first time that these kids actually had a chance to compete. Then we had our state ag mechanics CD team activity. We had 2 different tunnels. We did this at the very end of the day, so the kids had already gone through their individual skills. There were actually about 100 kids in the event, and what we have to do is all the teams have to do an online exam to qualify to come to the state event. So the top 25 teams out of a possible 40 in the state will actually qualify and bring their teams to our event. And then we use 2 different tunnels so we could facilitate having these students compete at the same time and finish up. So we had some pictures here of some of the teams that were actually competing in the event. And it's 200 points for the team activity. And so we based it on the highest scores of values generated by the sensors to help determine who the top teams were in this actual event. After the field day, we had a lot of interest again in continuing this. So the teachers from the Rice Intermediate School that were actually participating in one of our field days asked us to come up to their STEM night. So we brought up our wind tunnel and we brought up examples of the wind turbines to actually show the parents, the community. This was about an hour and a half drive from us. So we wanted to support their efforts again and to keep their projects going. So these are things that we just did in the follow-up of it. The Willow Bend Environmental Center up in the Flagstaff area, they host a KidWind Challenge for Arizona. And so we went up, we took a wind tunnel up to help them out with an actual wind challenge. And then we were very fortunate that in that year that the World KidWind Challenge was actually here in Arizona and Phoenix. So we took our tunnels up there to help out those folks, and we're involved with the judging and the participation of that event. So here we had teams from Mexico that were there. They had teams from Taiwan that were there. And then, of course, we found a young man from New Mexico, FFA, who actually had his jacket on. It was great. So we had to get a picture of him involved in the wind activity. Then our 4-H people were excited to learn what we were doing, so they invited us to do a wind turbine summer camp. This was in Maricopa, and we had about 15 different middle school kids that were involved in the building of the projects. Again, KidWind helped sponsor it, providing some materials, and then the 4-H picked up the rest of it. And so we had the 15 kids, divided them into small groups, had them build their own wind turbines, and we tested them. The downside of that is not every kid got to take home a wind turbine. So there were some tears. So it's like, oh, darn, they really liked it. We actually have 80 students that are going to be here in about 3 weeks on our campus, their state summit, and they asked us, hey, can you do this again with this large group of kids and put on a wind summit? You'll have 2.5 hours. So we're trying to determine, are we going to have 80 kids each build their own, or are we going to break them into small groups again? So we're working through that right now, planning this again. In the fall last year, again, we continued this with our Ag Technology Management course. So we see some students doing some different exercises and activities from the KidWind materials. Also, in this particular one, we allowed the kids to build their own individuals. So here's our students, each with their own wind turbines. And we did it as a competition for them, wanted them to see how that works. They got the 3 highest the 3 times that they could go into the wind tunnel, determine what their highest values were. And then we came up with our own little trophy. We called it, these were our wind champions. So we designed this on a plasma cutting table and then presented the student that had the highest score overall with their own little trophy. So a way to motivate and engage our college kids. And these are students most likely are going to be high school agriculture science teachers when they graduate. So again, we want them to see what this competition is, to get them excited about it and say, how can I, take this to my high school in the future and again, engage our students in this activity. So our future plans, again, we're going to continue this wind tech instruction. We'll do it again for the fall 2026. We had a meeting with our U of A College of Education faculty. We want to work with them to see how we can integrate this into our Tucson city schools. There is some interest in KidWind. We just haven't seen those schools participate in the past. We're going to include Wind Tech with our Arizona Ag Teachers, New Teachers Professional Development Program. We have about 30 teachers that are in years 1 through 3, that the association would like to get more hands-on activities such as this into their hands. So we will bring them on campus this summer for a 1-day professional development program, and we'll include an introduction to our KidWind to them. We are continuing our work with the 4-H and FFA. And then what we wanted to do is look for a funding source for acquiring solar lighting tables for both our program and Willow Bend Environmental Education Center for the solar activities. I noticed when I was up working with the folks up there at Flagstaff, they only had the wind turbines, and the solar is an important part of the KidWind activities. They said, well, we don't have a table. And we've had schools ask about it. So we're working on securing some funding this summer to see if we can get some wind tables provided out here, so we could have one here and have one up at Willow Bend, and then start training our teachers and integrating the solar activities as a part of that event. And that's all that we have on that. So thank you for sitting and listening. If you have any questions, be glad to answer them.
Yeah, thank you so much for that presentation. That's really great. If folks do have questions, you can feel welcome to type them in the chat, or if you'd like to, unmute and ask your question yourself, that's great. I will monitor the chat and moderate those questions for Ed. I had one comment for you, Ed. You mentioned sort of the nice synergy between the KidWind activities and the ag mechanics competition. And it occurs to me, as you look at the wind industry, obviously most of these wind installations are in rural areas. So, when you see kid wind competitions in urban settings, most of those kids have no exposure, no prior knowledge of the wind industry or wind machines.
Right.
They've seen pictures in books or perhaps on TV, but that's sort of their extent. And I think with the audience you're reaching, you're actually dealing with students that live in areas where this is an economic development story, where they may know people that work on farms or may be landowners that host these machines. I'm just kind of curious, with the various groups that you worked with, how much prior knowledge did they come in with? How much background did they have? And did that change their sort of curiosity and motivation in any way?
That's a great question, because I was trying to, as I got into it, figure out what impact does wind have on energy generation in Arizona, right? And then attending these KidWind seminars and Wind 101 by Mike Arkin, then I started finding out, hey, here it is in Arizona, right? We have a number of, and we're not going to see it in our area in southern Arizona, but as we move to the west and we get up on the rim, northern Arizona, where there's more open area, yeah, there's quite a bit of wind activity up there. We have different groups like AES, and then our local TEP, Tucson Energy, that is working with those systems up there. So they are available in Arizona, and we'll demonstrate it, show it to our students on class where these locations are. A lot of them are going to be up on the northern parts of Arizona, even up on the reservation areas, and say, okay, this is just a small portion of it. Most of what we're going to see in renewable energy generation is going to be solar activities, right? And we have solar storage now coming in real big in Pinal County. And we have a lot of utility solar projects that were once on farmland down there, right? And we have solar all over, even on campus here. And it's just really getting in it. And I found even through my students' class in the Gen Ed class, what is their knowledge, right, of it? And a lot of them didn't know that we had very much wind in Arizona at all. But a lot of those students had no idea that we even have a nuclear power plant in our state. So, this is just a hotbed for trying to get education out there on renewables, and letting them know that, what is out there. and how are we getting that energy to our houses.
The other thing I noted from your presentation, Ed, is it looked like you were reaching students from a lot of different disciplinary areas. Like there were some pictures that looked like science classrooms, some that were clearly, ag classes that you were working with, and then also the group that was in the welding shop and another group that was in an auto mechanic shop. It reminded me that I once remember talking to an industry person who was recruiting technicians to work on a wind farm, and he so this is basically auto mechanics, except you'd be doing it at lower speeds and much higher elevations. Uh,
Yeah,
and I think the nice thing
absolutely.
about this activity is it does reach across a lot of different disciplinary areas. And I was just kind of curious, did you find, certain groups of students that really took to it, and generated more interest than others, or really had aptitude that seemed
Yeah.
to sync well with the competition?
Yeah, it was funny working with the middle school kids and the 4-H kids because they're just, all into it and everything, and ways they see it turn, and of course, they're all about the numbers, right? So that is such the great to get them started, and it was just like I said, when you had materials that, oh, we're going to put them in groups of 3 or 4, and then at the end of the day, the parents can pick them up, and the kids crying because I don't get to take one home. It's goes someone, and can we share it? It's like, oh my gosh, these kids are really invested into it emotionally. That's great. Again, anytime we're doing something that's not traditional, welding, plumbing, construction things are very traditional in our agriculture mechanics curriculum. So when you're trying to bring something new that's not, there's that question of who should be introducing that, right? Is it the tail wagging the dog? Is it what we should be doing it at the university level, or should this come out of the high school level and then we're trying to measure? And I kind of wrestled with that because I was a former high school ag teacher for years. And so it's like, it should be generated there. But I also think that, this is where we know the industry's going, right? Where is energy generation going? So maybe it's my responsibility then to, again, take that knowledge and share it with the teachers and saying, here's where the careers are, right? If you're preparing for careers in the ag technology area, and especially in our state, energy is huge, right? So again, exposure to what's available out there, and then of course the applications to math and science. That's the other big thing. If I'm going to have teachers put this in the classroom, they're going to say, all right, what this sounds good, looks good, but what is it going to help me? Okay, here how they tie to your math and science standards. So again, it's just another tool for the teachers to do that. And that's why I was looking at getting into solar, because I was seeing my students were struggling with Ohm's law computations and resistance and things like that in series and parallel. And when I was able to bring solar in, it's like, aha, here's the difference, right? Pumping a bucket, one is here's a single cell, here's a parallel, and here's a series. What's the difference, right? Now they see it, they feel it, they hear it, they touch it. Okay, that helps them to really understand what's taking place.
Well, Ed, this has been a really inspiring presentation to kind of cap off our innovation series for the semester. Thank you so much for joining us today. We managed to go a little bit
Absolutely.
over time, which is fantastic. And we'll wish everybody a good conclusion to the end of your semester. And I know we'll continue to be in touch, Ed, and we hope to see you again on some future webinars.
Appreciate your time. Thank you, everybody, for giving me this time this afternoon or morning. And good luck to everybody finishing off the school year. Thank you, Ken.
Thank
Thanks,
you.
everybody. Have a good weekend.
Bye-bye. Thank
You
you, Kathy.
too.